All right, number 11, find the sine of A plus B if the sine of angle A equals 3 over 5, with A being between 0 and 90, and the cosine of B equals 8 over 17, with B being between 0 degrees and 90 degrees as well. With this, the sine of A plus B, we need to know the sine of A, that was annoying, sine of A times the cosine of B plus the cosine of A times the sine of angle B. We already know two pieces here, and we can just replace those right now. We already know the sine of A, and we already know the cosine of B. So that fraction is already going to be pretty easy to set up. So the sine of angle A is 3 over 5. The cosine of angle B is 8 over 17. Now what we're missing is these other two. We're missing the cosine of angle A and the sine of angle B. Going back to what we know about sine and cosine from when we first talked about SOHCAHTOA and the good old trig functions, we talked about them in terms of right triangles. So if we draw a right triangle, and you draw, I'm just going to call that one side angle A, the sine of an angle is always equal to its opposite side divided by its hypotenuse. So if we're using the sine of angle A as 3 over 5, we can say the opposite side to angle A is 3, and the hypotenuse is 5. Now with this in mind, we got to figure out what this fourth side is, because in order for us to do cosine of angle A, we need to do its adjacent over hypotenuse. Well, we already know the hypotenuse is 5. The adjacent side, you might be able to eyeball this and say, oh, it's 4, because that's a good old Pythagorean triple. If you don't know that, you can always go through and say, well, we'll call this side b squared. So we got 3 squared plus b squared equals 5 squared. Not 55, what in the world? In other words, 9 plus b squared equals 25. If we subtract 9 from both sides, we get b squared equals 16. In other words, our b value is 4. So b, that side is 4. So our cosine of angle A, we still don't even know the angle measurement, that's perfectly okay. But we know we can figure this out and say the cosine is equal to 4 over 5. So we can start plugging that into our equation as well. So we got plus the cosine of angle A, we got 4 over 5. Now for the sine of angle B, we're going to do the similar thing. We're going to make a triangle here. It doesn't really matter how you draw or where you put this angle, as long as you have a right triangle. My go-to is always just to put the angle that we're talking about in the lower left. So we know the cosine of angle B, so the cosine is adjacent over hypotenuse. So if we call this 8 over 17, we're looking for this side length here. So to figure out that side length, we'll have 8 squared plus, we don't know that b value, equals 17 squared. 8 squared is 64. Plus, still don't know what b is in this case, 17 squared is 289. To solve for b, subtract 64 on both sides. We got b squared equals 225. To figure out our b value, we'll take the square root of both sides. We end up with b equals 15. So adding that to our triangle. To find the sine of angle B, that last piece that we're missing, sine of angle B is equal to the side opposite to B, so 15 over the hypotenuse, so 15 over 17. So now we've got all of our fractions. We got the sine of A, cosine of B, cosine of A, sine of B. Now we can actually go through and do the multiplication. Taking care of that first fraction multiplication, 3/5 times 3/5 times 8 17ths. We got 3 times 8, which is 24. 5 times 17 is 85. Yep. Plus, second group, 4 times 15 is 60. Over 5 times 17 is 85. Adding those two together, 24 85ths plus 60 85ths. Add the numerators together because we have a common denominator. We got 84 over 85. So we can figure out the sine of these two angles without even knowing what those two angles are.